Okay, this is March 3rd, 2022. This is Physics 37 Lab. And we started working on the data for the first lab, which is measurements. We measured the diameter of 6 different spheres, right? I provided you with the data of the diameter of 6 different spheres, and you plotted the volume versus the mass. And I'm going to, we didn't cover everything last time, but we're gonna finish covering everything, and then we proceed with the normal schedule here for the classes. Okay, what we are doing for this lab, we're going to do for the other labs too, but for different experiments. Okay, that's what you're going to do. Here you go. We have, this is the data, the raw data for your experiment. And this is also raw data for your experiment. In order, what do I call raw data? Raw data I call something that we measured. We measured the diameter of the spheres with 3 different instruments, and you measure the mass of the 6 spheres with a scale. Okay? And then we plot the graph. I want to make sure everybody plotted the graph here. Okay? So all the 3 graphs, everybody must be plotting all the 3 graphs. Let's go through one by one. Here you go. Ortacelli, did you plot all 3 graphs? All 3 graphs. Do you have all the 3 graphs plotted, Ortacel?
Not as of yet. I'm having some trouble with my computer.
Oh boy. Oh. Okay, I need you to have it plotted. Okay, that's you need to have a computer that works, that's reliable, and you must have Excel installed on it. Okay, that's important that you do. What's the exact problem that I have with your computer? Explain that to me.
It was just highlighting, like how you had us highlight the volume column and the mass column, and then composing it into a graph.
Okay, so here you go. Let's do it. Okay, here you go. I'm gonna highlight the mass. Okay, do that on your side. I'll highlight the mass.
Okay, it's highlighted.
Okay. Now I'm going to highlight this one here. Okay. You have a Windows computer, right?
No, I have a Mac computer.
Okay. In the Windows computer, we press the Control key. In the Mac, maybe it's gonna be a different key. Okay. To highlight the second
Use the
column.
command key.
Oh, it's
it
the
has
command
the
key in
apple
the
on
Mac.
it.
That's right. Command key in the Mac. Press the command key and then you can highlight the second column. Okay.
Okay.
Do you have the 2 columns highlighted now?
Yes.
Okay, now you can plot. Insert. Shouldn't be very different from the Mac. Okay, that if it's not insert, it's something else. You should see the chart in there, and then you plot the graph.
Okay, great. I got it.
Okay, so you gotta do for the others as well. Here you go. Do highlight the mass, command key in your case, highlight the volume for the vernier caliper. And then you plot the graph again. Okay? When the 2 columns is far apart, when the 2 columns is far apart, you must press either the control key for the Windows computer or the command key for the Mac. Okay? You have to do that because the computer, that's the only way the computer is going to understand that you want to highlight those 2. I'm going to get there. Should look like a straight line, John. Should look like a straight line, okay? When the volume is next to the mass, you do not need to press the command key. You do not need to press the control key, okay? All you gotta do is to drag like that. If the cells, if the columns are next to one another, you do not need to press the control key. The control key still works, okay? But you don't need to do that. You don't need to go through this trouble. All you have to do is to highlight the 2 like that. Okay? So here you go, John. How the graphs look like? They're gonna look like that. Let me show. Insert, scatter. Here you go. Straight line. See that? Looks like a straight line.
Yes.
Okay. And what else you have to do? Here you go. You have to go through the same exercise that's spelled out in your syllabus. Go back to your syllabus. Okay, the syllabus is spelled out everything that you have to do here to plot a graph. Let's see. Here you go, right in here. Other factors, graphs, item 4. Okay? Okay? The graph must be clean and blah 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 blah, blah, right? You must label the axis. Okay, all that stuff you're supposed to have done last week. Okay, I'm doing that again. So I'm gonna need some time to fix it. Well, I need to. Who is that? Is that John? You're group number 3, John. Okay. You're group number 3, right, John? Let me get your graph here. Here you go. It shouldn't be scattered. There must be something wrong in there that you did. Okay, let me see. Or maybe the data is not good. Let me check group number 3 here. Raw data, group number 3. Group number 3, let's see. It shouldn't be scattered, John. Let's see what's going on there with your graph. Mass, volume for the ruler. Insert, chart. Yeah, that's okay. Yeah, that's a little bit scattered. Whoever got this data didn't do a good job. Let's see the second one. This one here. Maybe they have a better data here. But remember, this is a ruler, right? Is that this type of scatter that you're talking about, John?
Yeah.
Okay, so let's see
All
the
of them
second.
look like that
All
for
of
group
them?
3.
Oh,
Yeah.
that's bad. That's not good. Why is that? Huh?
Since they all look the same, would you prefer just put down one graph, or would you still like the whole 3?
Well, hang in there. Let me see what's going on. It looks like we have very bad data here that I didn't know. Insert. Let's see. Yeah, that's right. Why so bad? Okay, so I'll have to give you a different set of data. Okay, I don't understand why the data is so bad. Let's see.
Okay.
Yeah, let's see. 2, 3. Let's see here. 0.02. Let me order those guys here. Data. It's good that you told me that. So sometimes the students don't do a good job collecting the data. Let's see, Vernica. Let's go for micrometer, smallest to largest. Okay, good. So let's see, 0.0043. Oh yeah, see that? They have the same mass for different diameters. They didn't do a good job. Okay, they didn't do a good job. Yeah, they made a huge mistake when they collect this data. They put exactly the same mass for 2 different diameters. Let's see the rest. So that mistake that people do, okay? Increased, okay, decreased. See that? Decreased. So they made up. This thing, this data here, it looks like that they mixed up the larger diameter with the smaller diameter. Okay, that looks like that happened. See, the diameter is increasing. Okay, John, take a look. That's an example of data that was not collected properly. Okay, that's an example. It happens. It happens. If you are tired, if you do not know how your equipment works, if you're not properly organized, you get data like that that doesn't make sense. Okay. And so here you go. The diameters, are they increasing? Let's see if they're increasing. 13, 15, 15. Yeah, 15, 36, 17, 22. Yeah, the diameter, it looks like they got good data for the micrometer. It looks like. But they didn't do a good job in the mass. Okay? See those 2 diameters here that are different, they got the same value. This diameter that's larger than the other got this value, but then look what they did. A larger diameter, they're getting a lower mass. So it looks like they mixed up this mass with this one. Okay? That's what looks like that they did. And here, so the problem is twice, right? One, you have 2 masses of different diameters with the same mass. Okay, big mistake, right? So if you're doing your experiment, you should pick up those mistakes. And then they are telling me that the mass of the smallest sphere is greater than the mass of the larger sphere. That's what they're telling me. So apparently the problem is in those 4 data points here. The other ones doesn't look like it's a problem. No, it is also a problem because this one here is smaller than this one. See that they really blew up the data. I'm gonna give you a better data, okay, folks? Let's see, and then you tell me if you have a problem like that again. Let me, any other group has any problems like that? I'm going to delete this thing here, okay, and I'm going to renumber. I'm gonna delete this one because this one is not good. The guys who were, and I'm going to rename this one as being group 03. Okay, and I'm gonna use this other one here, okay, group 3. Use this spreadsheet that has different data. Hopefully it doesn't have the same problem that the other one has. And thank you very much for telling me that, okay? Let's see, let's go. But keep that in mind. It's things like that happens in experiment. Okay, and those things happen not most likely not because the measurement equipment is bad. No, it's because of bad measurement technique by the whoever is doing the experiment. Okay, I have seen mistakes like that, and then the student go back frustrated. The experiment doesn't work. Okay, well, the experiment doesn't work most of the time. Most of the time when the experiment doesn't work, that's because the student didn't do the measurement properly. Sometimes it is because of the equipment. Sometimes it's because of the equipment. But whenever the equipment is not working, I can see it right away that there's a problem with the equipment, okay? I'm going to upload a new spreadsheet for you folks, group number 3. No, it's not P38, it's P37. Group folder, group number 3. Okay, I'm gonna delete this one. You don't do that. You don't need that anymore. Remove it. So even bad data is an opportunity to learn. Okay. Yes, you should delete your old downloaded spreadsheet. That's right. And then just start working on this other one that I posted for you. Hopefully it has good data there. If it doesn't have, let me know. Okay, and I will provide you with another. So it's seen there. So I went here a little bit in a tangent, right? So let's go back to the. Go ahead, plot your graphs. Let's see, everybody. I'm gonna check with everybody here. Now you know what to do, right, Artacelli? Are you there?
Yes, I actually plotting them.
You're plotting them, and don't forget to follow the syllabus, item 4, the graphs, if any. Okay. So let's do that. Let's first see. Let me first see with every student if they were successful. Let's see. Ernesto, were you able to plot the graph, Ernesto?
Yes, sir. After you're done, question. Are we supposed to are you gonna verify them or
Verify what?
our info, our graph?
Well, I will now. What we're going to do? You are going to plot the graphs. You're going to play. Type all the numbers there with the proper significance figures. You're going to prepare your lab report. I'm not going to check your data right now. Okay, I'm not going to check your data right now because there are other things that I have to cover with you. Okay, now I'm going to check your data only after you upload it to your group folder, unless you have a case like group number 3, right? That they just got bad data. Okay, unless you have a case, I don't think that's your problem, right? Did you have a straight line? Do you have a nice straight line there, Ernesto?
For the most part.
Yeah, for most part. Okay. So I'm gonna say that you have a good data there. Yes, right?
Yes.
Samuel, do you have any problems, Samuel?
No, I don't.
You didn't? Okay. So let's see. I'm gonna plot the graphs for you. Okay. for group number 1, and then I'll do that for every group here. Here you go, group number 1. Should be something like that. Here you go. Don't forget, folks, you have to put that in the proper number of significant figures. Remember that? 3 decimal places, 4 decimal places, 3, 4, 5 decimal places, right? You gotta put that in the proper, and here too, significant figures. I'm gonna show you how to do the graph, right? First graph for the ruler. Let's see how it looks like. Okay, yeah, looks pretty good. It's a little bit off, this one. This one we call an outlier.
Yeah, that's the one I was telling you about.
Yeah, that's okay. It's not that bad. Did you see how was group number 3 data was?
Yeah.
The group number 3 data was hopeless, okay? This one, well, you can play with it. That's okay. It's not that bad. You can see a clear straight line. It's just this one that's considered an outlier. The next one, let's see. The next one, that's group number 1, right? Yeah, better, right? Because it's a vernier caliper, see? 1, 2, 3, 4. See, it looks to me that they didn't get the mass of this one properly in the. No, it's not the mass. It's something else because the volume divided by the mass. Yeah, something happened. I don't understand how they got this point. I really don't understand how they got this point here. Let's see here. Volume. Oh, I think I know what's the problem. Oh, no, it's not the volume, it's the mass volume, okay? So let me see. The problem is the diameter. That's the problem. The diameter, when they measure with the ruler, they got way off, okay? That was the problem here. Most likely, which point was this one? Let me see which point was this one. 3, must have been this one here. Must have been this one here. Yeah, must be this point. Let's see, 0.0175. And then what did you get for the next one? Yeah, see, it's a big difference. It's a big difference. Yeah, it's a big difference. So the problem is when they measure that with the ruler. That's why you're having this big difference right in here. Okay, so when they measure this point here with the ruler, they didn't get a good data. So you can see that big difference, right? Now let's take a look at this other one. Each press on the plus sign on the chart. How do we label? I'll get there. How do we label the x and y axis? I'll show you how to do that. Okay, would you like mass? Yeah, no. It has to be mass on the y-axis. Sorry, folks. Mass on the y-axis and volume in the x-axis. Okay. Should we delete our? Yeah. Okay. Okay, Dino. So the mass is already here. So every time that a column is to the right of the other column, it means that this column will end up in the y-axis. That's by default. That's how Excel works. By default, when you have two columns, the columns on the right will end up in the y-axis. So when I designed this spreadsheet, I already took that into account for you to make things easier for you, okay? So I'll get to you how to label the axis. Let's see. Okay, so let's plot the last one. Yeah, okay. Yeah, pretty good, right? Yeah, let's see. Yeah, just a little bit different. So the problem is this guy. The problem was the measurement with the ruler. Okay? They measured this point here with the ruler. They didn't do a good job. They didn't do a good job. The y-axis is the y-axis is the mass. Okay, I'm sorry. The y-axis is the mass. Let me write down here for you. Did I put that here? Yeah. Plot the mass on the y-axis and the volume on the x-axis. See that? If you do that, the slope of your graph is going to be your density. Now, let's do that again. Now we need to label the graphs, right? Label the axis. Okay? First, I don't like a title to the chart. I don't like. Delete that. Highlight it and delete it. I think it's unnecessary. Okay? Take a look at those numbers here. Okay, take a look at those numbers. Let's see. They are 10 to minus 3. Because those numbers here is more than 0.001, I recommend that you use a format, a numeric format, not a scientific format, okay? Because those numbers are greater than 0.001, I recommend that you use a format, a font format that, no, not here, let's see here. Right click, format, okay, the way you do is like that. Double click, here you go. Now we have it here on the right side. Look for, numbers here at the bottom. Okay, you have this guy highlighted. Look at numbers here, and I'm gonna put in numeric format. Right now it's scientific format. I'm gonna put it in numeric format, and I'm gonna put 3 decimal places to make it look better. Okay, looks much better now, right? I didn't put the labels in the axis yet. I'm just changing the format of the numbers in the axis. Those guys here are less than 10 to minus 3. So keep it like that. See that? 0, 5 times 10 to minus 7, 1 times 10 to minus 6, and so on, right? What I like to do, the axis, the numbers that are in the axis, I like to put them in boldface. Boldface, here you go. Boldface. And I also like to put them in a large size, otherwise it's difficult for me to read. Here you go. See that? Boldface. I'll put this one in boldface as well. Boldface. Size 12. Alright? I don't like that those numbers are too close to each other. They're too, So we are going to do something else. Those ones are not too close. I think it's okay. It doesn't look good, it's difficult to read. So what do? Double click here on the axis. This panel opens up and you change the major units. I'm gonna multiply that by 2. So instead of 0.005, the major units, I put 1. And look what happens. I cut down in half the number of numbers that shows up in the y-axis, okay? Now we are going to label the axis. We're going to label, are you all following? Okay, the y-axis is going to be mass, okay? So here you go. Watch what happens when I click watch here at the top what happens when I click the graph. When I click the graph, what happens? See, something else shows up, right? I unclick the graph, they disappear. Click the graph. We are going to use either one. To get the label to the axis, you click on chart design. And then you go to add chart element. Okay? Add chart element, and then you have axis. See that? You have axis title. We want axis title. Primary horizontal, axis title, primary vertical. See that? Here you go, axis title, axis title. I always keep my axis title with larger face, larger font. So instead of 12, I'm going to use 14, maybe 15, 16. And boldface too. And then you go ahead and write that down. Volume. Volume, capital V. Capital V, don't spell out volume. And then you put between parentheses cubic meter, right? Which is the unit of volume. I'm going to highlight the tree, right click the tree, and make it a superscript. Okay? When you publish papers, you will have to do all of that we are doing here to make all your graphs look good. Okay? Nobody will allow you to publish a graph like that here. Nobody will let you publish a graph like that. Or even presentations, okay? It looks very bad if you present a graph like that with no with no labels, nothing like that. Okay, what about here? Well, you do the same, right? Bold face, this size is going to be what, 16, and then you type mass unit kilogram, unit between parentheses. It's not everything yet. Let's take a look at the syllabus, right? Here goes syllabus. And the graph must be clean and planned to optimize its space, no large blank areas in the graph. I will determine blah, blah. You must label the axes of the graph with their proper units and their corresponding units between parentheses, with their proper quantities and corresponding units between parentheses. Okay? That's where we are. How do we optimize the space? Let's see. I did that last time too, right? We can optimize a little bit the space. It looks like we have too much space here. But wait a minute. 1, 2, 3, 4, 5, 6. Yeah, okay. Let's see what's going on here. Oh, wait a minute. 1, 2, 3. The problem was not this data point. Huh? The problem is not just this data point. The problem is those two data points. See that? Those two data points are not in good shape, okay? But that's okay. Everything else seems to be fine. See this this numbers go into 4 times 10 to minus 6. So this group of students didn't get good data for those two data points, okay? So the outlier is not this one, it's not just this one, it's this one too. It's this one. It looks like this one is more of an outlier than this other one. The real outlier is this one. Okay? See? It goes from 0 to 6 times 10 to minus 6. Here it goes from 0 to 4 to 10 to minus 6. That's because of this point. They came down with a very small diameter. Okay? But like I said, sometimes those things happen. And especially with a ruler, that's so difficult to measure the diameter of a sphere. I'm going too fast. So let's see how we're doing there. Let's go each student. Conrad, are you okay there, Conrad? Did you plot out the 3 graphs? Roy Conrad Dubuque. Yes, it's plotted. Okay, good. It's not just plot the graph. There's more to do, right? Sokavi, are you okay? Did you plot the graphs, Sokavi, all the 3? Yes, good. Robert Supelsa?
Yep.
Yeah, okay. It's not just plotting the graph. You also have to do the trend line, right?
Yep.
Trend line. So did you, I presume that, let's see, Robert Supelva, did you do the trend line as well?
Yep.
Okay, trend line and R square, right? Trend line and R square. Here you go. Did you do the R square too?
Yep.
Okay, some students didn't do, so we're going to cover that again. Aidan Samora. Aidan Samora. Did you plot out the 3 graphs, Aidan?
Yeah.
Yeah. What about the trend line and the R square?
I'm not sure about that one yet.
Okay, we're gonna cover that. I'm gonna put no and no here. Nathan Lillian, did you plot out the 3 graphs, Nathan? Yes, good. Trend line and R square, Nathan? Yes, okay, good. So you're ahead here of many people. John, John, you are plotting. Did you plot the 3 graphs and did you get the trend line and the R square?
I plotted the 3 graphs, but since we're starting on a new one, I
Okay.
forgot how to do the trend line in our square.
Okay, so I will cover that very soon. Bear with me. Dino, did you plot the 3 graphs? Did you do the trend line and the R square?
Yes to both.
Yes to both. Okay, don't forget that there is the syllabus has.
You can't be sitting there.
Okay. Don't forget that the syllabus spell out how to do the trend line and the and the R square. Evan, Matthew, Hilario.
No, I did not.
No, none of them.
Yeah, no.
Okay, so I need you to. Do you have the graphs? Do you have the spreadsheet there with you?
Yes, I do.
Okay, so start
I'm
working on
plotting. I'm
that.
plotting right now.
Start working on that so you can catch up, okay? Ryan McNeil. 3 graphs? No? Not even the 3 graphs? No trend line, no R square. You gotta do that, okay? That's gonna be your last opportunity before you turn in the report. Joe Romero. 3 graphs, yes, all good. Okay, trend line and R square. Okay, so work with your group members, okay, to help them out, Joe. Franz Darwin, Sul.
Yes, Professor.
All the 3, good.
Yeah.
Okay, Evan John Hilario. Yeah, just the 3 graphs. Okay, so Kevin Lopez.
Just the 3 graphs, Professor. I still haven't gotten the trend line or the R square yet.
Okay, we're gonna do that again. Roberto Melena.
Yeah, so all of them.
All the 3 graphs only?
3 graphs, a trend line, and the R square.
Okay, okay. So interface with your group members, help them out. I'm gonna walk you through the trend line again, okay? And again, don't forget, it's all spelled out in the syllabus, okay? We did the labeling, okay? Ensure the number along the axis are properly spaced and not encroaching on each other. We did that as well. Do not connect each point, each data point with straight lines. Instead, fit the best curve to this data.
Professor?
Yeah?
Are we supposed to individually send this to you?
No, it's a group. But
as a group.
But during the meeting, you must be doing this plotting as well, because you have to learn how to do that. But after doing all the plotting, you're gonna get together with your group members. You're gonna come up with a single report, a single group report, and then you submit the spreadsheet and the hard copy to your group folder. Okay.
Okay. Thank you, Professor.
Okay. So here you go. Do not connect the data points with straight lines, right? Ensure them. Let's see here. Click. Let's see how the graph moves. You must label the axis. Oh, I need to put a little bit more of instructions here, right? Is there a proper point? The graph must be clean. How to determine? Okay, graphs, if any. Well, here is assumed that you already know how to. The graph. Let's put it. The graph must be scattered. The graphs must be most of the time. Okay, most of the times, not all. Most of the time, the graphs will be scattered plots. Okay. It's not most of the time. It always. Yeah. I don't do. Let's see. The graph. If the all graphs will be scattered plot unless I tell you otherwise. Unless I tell you otherwise. Okay. Let's put it this way. Unless I tell you otherwise. Scattered plot. Now we are going to, at this point, you should have all the 3 graphs plotted. For the x-axis on the ruler graph, did you need a certain amount of? No. No. The only thing you worry about significant figures only on the spreadsheet, not on the graph. Okay? You worry about significant figures only here. Okay? Not in the graph. In the graph, that you don't have to worry about significant figures. Otherwise, it become crazy, right? Here you go. If you, I got the plot, right? This one, yeah. See, I didn't worry about significant figures here, but you have to worry about significant figures here on the table. Okay, so now we are going to put the trend line and the R square. Okay, so how do we do that? I have it here, one of the graphs already. Here you go. How do you come up with the trend line? Click one of the data points. When you click one of the data points, all data points end up highlighted. Okay? That's the first step. And it's written right in here. Clicking one of the data points of the graph. When you do that, all the data points in the graph are highlighted. Next step. Right click one of the data points. Right click one of the data points. In the drop down menu, highlight add trend line option. Okay? right click any of the, okay, here you go. Add trend, here you go, drop down menu, add trend line. And then this panel shows up. Notice that you have three choices here, right? Notice that you have three choices here. Make sure you get the right choice. I was lucky enough to have the right choice chosen. And then do you see that the trend line plotted?
You think you're cool?
Okay. There is a mathematical procedure to find this trend line. Okay, we call it the method of the minimum squares. There's a mathematical, is a statistical procedure. Okay, that's already programmed in Excel, but you can do that manually too. It's gonna take forever for you to do, but you can do that manually to derive this equation. Okay, that's what's the nice thing about computers. They already have all that hard work programmed in there to save you time. Imagine when I was doing undergraduate school back in 1981. Okay, everything that we are doing with computers at that time, we were all doing by hand, folks. We would get the data there in the lab, would not plot because there was not time to plot, right? I didn't know if the data was good or not. My classmates didn't know if the data was good or not. We would go home and plot those graphs by hand. Ruler, pen, pen, pencil, eraser, and put all those dots in the graph by hand. Okay? It was hard work until computers came into place. Okay? Back in 1981, there in Brazil, we didn't have microcomputers yet. Okay, that's when microcomputers start to come into the market, but it still was too expensive for everybody to buy it. The first time I started working with microcomputers was in 1985 in Puerto Rico, no longer in Brazil. Okay, so let me see. Oh, wait a minute, I did a mistake here. Let's do that again. Click, highlight everything, right click, add trend line. Here you go. We have the linear and the linear plot here. Go down in the panel, display equation chart, display R square on chart. That's what I want to know. Okay? Now see the slope of this graph. Okay? Because of this data point here that's way off, not as much as this one is not as much as the other, it's this one that's really screwing up with your data. We are getting this high density. The density of steel is not 12,531. No. The density of steel is around 8,000. But what is affecting the density of the steel is this outlier here. They didn't do a good job here with this outlier. The diameter, they got a pretty bad diameter for this. So it's this one here, okay? Let me see, 0.018, 0.018, let's see. 0.022, see that? Yeah, they did a pretty poor job here when they measured the diameter with the ruler. Here is 0.018, 0.022, see that? 0.022, 0.022, 0.022, 0.018, 0.0. So they did a pretty poor job here when they measured the diameter of this larger sphere with the ruler. And you do the same for the vernier caliper and the micrometer. Now take a look what's gonna get for the slope. See, 7,961 is a more reasonable value. It's a more reasonable value. Okay, then 12,000. You are getting this poor value again because of this guy right in here. Okay, I can even, if I eliminate from my plot, I will be able to get a better slope. Closer, but it's not much closer than that. It's closer than the other ones, right? So it became 10,000 just because I eliminated this outlier here. It's still not good, okay? Because there's something wrong here with one of those points. But anyway, folks, we're talking about a ruler. We're talking, it's very difficult to measure diameters with a ruler. Okay? So when you are analyzing data, you are doing this type of exercise. You want to find out which one is the outlier, right? If I eliminate the outlier, the result becomes better. Okay? And then you gotta do for this one as well. Right? So now you should, and then what you do next, you write down the number of data points, you count 1, 2, 3, 4, 5, 6, 6, 6, and 6. That's the name of data points, the number of data points. You write down the regression equation, copy this equation here, paste here for the ruler. Copy this equation here, and paste here for the vernier caliper. Okay? And then write down the R square for each of those graphs. R square, R square, R square. I cover all of that. And then what else do you do? You log the slope. The slope for the ruler, the slope for the vernier caliper, the slope for the micrometer. Okay? Go ahead, do that now. What I didn't cover, up to now I covered everything last time. What I didn't cover and didn't have time to cover was this part here. Okay? That's a little bit more difficult. And you're not gonna find in any book, okay? You're gonna find books, but it's difficult to find it. It's hidden in statistical books. Okay, so remember I'm recording this class. If you want to review it, you'll be able to review. Okay, so here you go. Here, the ruler vernier caliper, okay? You must have plotted all the three graphs. All the three graphs must have each of the three graphs, right? Each of the three graphs must have. Where did you want the equation in the graph? I'm gonna get there. Hang on. Must have the regression equation and the determination, that R square we call the determination coefficient. There's a name for that, R square. It's called determination coefficient. R square is determination coefficient. R, which is the square root of R square, is called the correlation coefficient. Okay? I'm going to put here between parentheses, R is called the correlation coefficient. Where did you want the equation in the graph? Okay, here you go. You see it's already here, right? When you click the equation in the graph and the R square in the graph, it's going to put somewhere here in the graph. Okay, you may drag anywhere you want. Okay, Roy, anywhere you want. Preferably make a larger format so you can see it better. Remember at least 12, right? Yeah, 12 is good. No, 12 is small. No small fonts, please. Yeah, and preferably bold. Some things you should put boldface, so it makes it easier for me to see. Right? I'm gonna talk about the CL very soon. Okay? So the slope is 12,531. You put right in here. The slope for the ruler. See, it's all labeled. The slope for vernier caliper, the slope for the micrometer, and don't forget the units for the slope as well. Okay? Again, n is 6, 6 and 6, the equation goes here. You copy the equation, the right side of the equation, paste here. And you either copy or type the R square and add in those cells. Let's see how you're doing. Now, Ortacelli, did you get all the three graphs, Ortacelli? Yes? Trend line and R square too? Hello, Ortacelli?
Yes, I got it.
Okay, good. What about Ernesto? Did you get the trend line and the R square? Ernesto?
Yes, sir.
Yeah?
Yes, sir.
That's a yes, right?
Yes, sir.
Okay, good. Thank you. Samuel?
Yeah, go ahead.
Yeah? Okay, Roy, did you get trend line and R square, Roy? Yeah, okay, good. Don't forget also the labels, right? It's not just the trend line, but also the labels and so on. Sokavi, did you get? Yes, good. Now, what about Aidan? Did you get the trend line in R square now, Aidan?
Uh-huh. Yeah, I got it.
Okay, good. I want to move to the correlation coefficient. Let's see. John Lords, did you get? John?
Yes,
Trend
I
line
got
and R
both.
square. Now, what about, okay, Evan, Matthew, did you get the three graphs, the trend line and the R square?
Just not the R square.
Okay, good. So you're getting there, right? Good. Ryan McNeil. Yes, all the three? Good. Now the last, Ryan. Okay. Hilario, Evan, John, Hilario. Did you get the trend line and the R square? Yes, okay. And Kevin Lopez.
Yes, I'm getting it down.
Okay, okay. So let's go. Now we can move on to the CL. Okay. Let's see. Okay, CL stands for correlation coefficient. Okay. This is a little non-statistical concept that I find very useful. If you took a course on statistics, you should have learned about the correlation coefficient. The CL is a measure of how good your regression, how close, not good, no, but how close your regression equation is to your experimental data points. Okay? It's a little non-statistical, little used statistical concept that I find very useful. The CL is a measure of how close your regression equation is to your experimental data points. CL can be anywhere between 0% and 100%. If you get a CL that is closer to 0%, that means that your equation does not correlate well with your data. Okay? So your regression equation. Okay? So there is a difference between a model versus real life. Okay? There's a difference between a model versus real life. Okay? So in this case, your regression equation, is a model for your real life set of data points. Okay? Your regression equation is a model. Regression equations can be used to predict the behavior of systems. Okay, that's what regression equation can be used for. The closer your regression equation is, is to your data point, the closer your CL will be to 100%. Okay, the closer, I already said that. So here is your prediction, and here is your real life. Your prediction don't always end up close to your real life, okay? But here in those experiments that you're going to perform, they're going to be pretty close because those experiments work pretty well. Unless, of course, you don't have good data. That's what regression equations are all about, okay? So how you're going to measure how good the regression equation is, you measure it using the CL. Not just the CL, but you also measure it using the percentage difference as well, okay? The percentage difference as well. So two ways of getting an idea of how good your data is. The CL and your slope. Now let's see how the CL is determined, okay? Let's see how the CL is determined. I'm going to get, you have to use a table, okay? A special table that I prepare for you to find the CL of a data set. You must use a special table that are available in statistical books. Okay, I'm going to provide this table, and I will provide with this table. By the way, my lab manual has this table in the appendix. So if you have my lab manual, you already have that table there at the end. So let me get this table here for you. I'm gonna put that in the shareable folder, okay? And let's see, it's going to be in one of my, must be here, shareable folder. Let's see if it's here. Confidence level, right in here. I'm going to move elsewhere. This table, I made this table myself. I figured out how to calculate the confidence level. Not every book tells you how to do that, by the way. I had to figure that out on my own. And then I came up with this table that's not available anywhere else. This table of mine is far more detailed than what you are going to find out in the internet. Okay, so here goes Spring, right in here, shareable folder. Here you go. Go ahead, folks. Download this table to your computer. Okay, you are going to need it for the rest of the semester. And if you take Physics 38 with me again, Lab Physics 38, you're going to need that again. What time is that? 8:40. We're coming close to our break. Okay. I think it's a good, let's stop right now. Yeah, let's take a break. Otherwise, you're going to get burned out. We're going to go for a 15-minute break. 15 minutes break. It's 8:41 right now. Break till what? 8:57. Yeah, 8:57. Okay, 8:57. And then we continue with this CL. That was the only thing that I didn't tell you last time. Okay. And so let's take this break, and we'll be back in 15 minutes at 8:57. Any questions before I go into the break? No? Let's see. We have 17 students here. Let me see how many students. Let's see here. Make sure I have everybody in my attendance list. Yeah, 17. We're in good shape. To the CL, right? That I want you to learn very well. I'm gonna get the more coming here. You go 2022 shareable folder, confidence level. Go ahead, download this file. I want you to learn how to use this table. Like I said, you're not gonna find any table like that out there as detailed as mine. If you go in the internet, you're gonna find tables that are far shorter than that. Okay. So here you go. First time I came up with this table was 2015. You know, it's remember that I told you that the CL, here you go. Here's the CL. Here's this row for CL. What you're going to need to find the CL, okay? I'm gonna write that down here for you folks. How to find CL. How to find CL. Okay, CL is a function of two parameters. It's a function of the number of data points n and the determination coefficient r squared. You have both n and r squared, so you can find CL. Okay? So here you go. Okay, what you have to know, there is no analytic, no, there is an analytical form. There is an analytical form for CL, but it is a very complicated function. For this reason, we build instead a table that you can use to find out the value of CL. Okay? Remember, CL is a function of n and r squared. If you have those two values, you can find what the value of CL is. Okay? And you have to learn how to use this table. You have to learn how to use this table. Okay? For my labs, you have to learn how to use this table. You must, right? Must learn how to use this table. Here's the table. Oh, not this one. This one is something else. Here the table. Okay. Note that we have n here. N is the number of data points. Okay. So let's see. Let me get to my download. Here you go. Yeah, I gotta go there. What's going on here? I want it in PDF. Here you go. Let me see if I can get open. Yeah, here you go. Good. I guess I got it now. I got it in PDF. Okay. So here you go. Notice that it starts at n equal to 3. Okay. For less than n equal to 3, you cannot get the CL. For n equal to 1 or 2, you cannot get. You have to have at least n equal to 3 to get a CL value. At least. We are using for our data n equal to 6. Okay? So you have to concentrate on this row. You do not need to worry about this column here. This column is just n minus 1, minus 2. Okay? See? 3, n equal to 3. This number here is called the degrees of freedom. You don't have to worry about this column. What you have to worry about this column here and this row right in here, plus the body of the table. The n, you already know where it is located. Okay? And your r squared is this table right in here, is this body of this table. Okay, I can even come up with a nice illustration of this CL table, genetic illustration of the table. Okay, it's going to be something like that. Okay, let's see here. I want to. Okay, the table is somewhat like that. Here you go. Okay, here's the table. It's gonna put black and fill white. I'm going to draw a simplified version of the table that you're seeing there. Okay, and the simplified version of the table is like that. Here you go. CL is here. And I have CL values of 0.95, which is 95%, 0.99, which is 99%, 0.999, that's 99.9%. And then I start writing it in a different format because it's easier to read this way, okay? 10 to minus, let me take a look at the table again. Yeah, I start 90, okay. 10 to minus 2, 10 to minus 3, right? 10 to minus 4, 10 to minus 2, 10 to minus 3, 10 to minus 4, 10 to minus 5, and so on. Superscript. Ten to minus 5. Ten to minus 6. 10 to minus 7, and so on. Okay, so let me see, do we have any message here so far? No. And then I'm gonna show you, if you go to the table, notice that I'm ignoring this other row, right? Here is what we call alpha. You know, CL plus alpha is equal to 1. See that? The 10 to minus 2 alpha here is right in here, 1 minus 10 to minus 2. 10 to minus 3, 1 minus 10 to minus 3, and so on. My table goes only up to 10 to minus 7. Okay? Towards the extreme left, CL is 0. Towards the extreme right, CL is 1. I can go all the way up to 10 to minus 7. My table finished at 10 to minus 7, otherwise I have to make an infinitely large table, right? It wouldn't be practical. That are the values of CL. What I have in the vertical direction is N. Okay, N. N equal to what? 3. 4, 5, 6, 7, 8, 9, 10, so on, right? That's where N is located. 11, 12, 13, 14, 15, 18, 19, okay, and so on. And then you have the body of the table. The body of the table is this one right in here. Here you go. I'm gonna make it the body of the table is smaller. Okay, the body of the table is your R square. What's going on here? I'm gonna do differently. Yeah, okay. R square. I'm gonna make it very large. Superscript. And I'm gonna increase the size of this guy so you know what I'm talking about. Even larger, maybe 200 size, font size. Yeah. No, just to emphasize that the R square is the body of the table. Okay? Larger. So that is a very simple way of explaining what you have in that table. Here you go. That's you must have that in your mind when you start working on that table. You must have this picture in your mind, otherwise you won't know what you're doing. Okay? This simplified picture makes sense. And now we are going to practice working with this table and so on. We're going to practice working with this table. Don't forget, to the extreme right, you have the 1 here, which is 100%. To the extreme left, we have 0, CL equal to 0, which is 0%. Okay? Now let's do some exercise, Let's see, I'm going to give you a very simple exercise, a very simple example on how to use this table. We have, n equal to 6 here. Okay? Suppose, okay? I'm gonna get, let's see, I'm gonna get those numbers here for n equal to 6. Again, when you're reading this table, you're concentrated only in this column, in this row, and in the body of the table. You can forget about the rest. You can forget about this one, you can forget about this one, okay? So here you go. So suppose that you have n equal to 6. And somehow, and you got in your experiment an R square equal exactly, You're not gonna get that because it's very difficult to get something like that. R square equal to this value, which by the way coincides with this one right here that you're seeing. Suppose, okay? Example on how to use the table provided to determine CL. Suppose you have n equal to 6 and r squared equal to this value. And, you go find CL. Find CL. Exercise, simple exercise. The way you do it is to, here you go, n equal to 6, and that's the value that, let's say, you got in your graph for r squared. 948808. What is the CL? Okay, all you gotta do is, go up to here and then read at the top what's the value of CL. The value of the CL in this case is 1 minus 10 to minus 3. Okay? Make sense? Okay, here you go. Value is, CL is 1 minus 10 to minus 3. Minus 10 to minus 3, which is equal to 0.999. Okay. Another example. You know. Another example. N equal to 6, and now my r squared is going to be different. Let's say r squared is going to be something like that. Nine nine eight three six seven 99837. Find CL. Okay, just like before. You are going to go up until you reach the row for CL. 1 minus 10 to minus 6, and then you write that down. 1 minus 10 to minus 6, and then that should be how many? 1, 2, 3, right? 10 to minus 3 is 3 decimal places. 10 to minus 6 is 6 decimal places. I can even put a comma here so you keep track of the decimal places more easily. Okay, that's how you use the table. That's a good way of understanding how the table is used. In real life, you are not gonna get exactly those exact values of r squared. In real life, you're gonna get values in between what you see here. Okay, so let's take a look at one of the graphs here. Here you go. We have this r squared 9993 and equal to 6, right? Here you go. R squared 9993. Here you go. And equal to 6. Okay, so let's see if you have 9993. Do you have 9993 here? You have 99484, 9983, 9993. No, you don't have 9993. You have 9994836. 9993 is between those two values here. Falls somewhere between those two values. So what you are going to write down? You're going to write down your CL at the lower bound of CL that I call the CL min, and the upper bound of CL that I call the CL max. Okay, so what you're going to do, you go here in your, see that here? That's gonna be the vernier caliper, right? It's gonna be equal 1 minus, let's take a look again at the 10 to minus 6 and 10 to minus 2. You always put an equal sign here, otherwise Excel will not recognize this as a number. Here, the other one, oh, not this one here. Max, CL max and CL min. 1 minus 10, 2 minus 7. Okay? Well, it's showing 1 because I don't have enough, don't have decimal places, right? Don't have enough decimal places. So I must increase it. Here you go. Now we got it. Did you get the idea? Let me see if I can put decimal commas there. Yeah, I can, but they don't put decimal commas on the sum. Okay, unfortunately for that. Makes sense? So that's how you find your CL. You're going to do that for the ruler. You're going to do that for the micrometer. Because your ruler here gave you an R square that's lower than this one, so automatically your CL is going to be less for the ruler than it is for the vernier caliper, okay? I want you folks to practice that right now. And that's what was missing from our last meeting. How to use the CL table. You will be using that for the rest of the semester, and if you take my P38 lab as well. Okay, so let's see how we're doing there. Now it's CL, right? So, Ortacelli, did you download the CL table?
Yes.
Okay, do you know how to use it?
Yes, I just inputted it right now.
Okay, good. Don't forget, again, I'm going to repeat that over and over again. I frequently, I see that all the time. Students, they don't put the equal sign. And when they don't put the equal sign, Excel treats this guy here as a text, not as a number. And when I correct that with my software, it's going to mark you out. You're going to mark points out of your lab report, okay? Make sure you always put an equal sign here, always. And Excel is going to do the math for you. You don't need to keep on counting decimal places to write down your number, okay? 10 to minus 6 1 minus 10 to minus 6 means that we have 6 nines. 1 minus 10 to minus 7 means that we have 7, okay? 7 nines. So that's mistakes. One of the mistakes that student makes is this one, okay? That's one of the mistakes that student make. Another mistake that student makes, they don't subtract. They put, I see that all the time. They put a multiplication sign here, okay? They put a multiplication sign instead of a minus. And when they put an equal sign, that it doesn't end up being 0.9999. It ends up being 0.0001, okay? I see that all the time, every semester. Both mistakes. I say both mistakes every time, every semester. I want an actual number here. It's the lower bound of the CL and the upper bound of CL. Let me see. There are some messages here. Professor, in the left side column, what's N? What is N? N is the number of data points. Okay. How do you get the minimum and max? Okay. Do you understand that now, Samuel? Okay. Minimum and maximum. Again, here you go. Let's do that again. I did an example here. Here you go. 9993, right? 9993. Go back to the table. N equal to 6. Look where 9993 falls. See? Do we have 9993 here? No. It's larger. It's larger than this one. Yes, it's larger. It's larger than this one. Yes, it's larger than this one. It's larger than this one. Yes, but it's less than this one. 9993 falls between those two R squares. 9993 is your experimental R square. Your experimental R square. And those here, what you have here are the R squares that are the critical values of R square. Okay? So, how do we find the CL min, CL max? CL min, CL max correspond to those two here. This one is CL min, or the lower bound of CL. And this one is the CL max. That's the upper bound of CL. Okay? So your CL lies somewhere between those two values. anywhere between 1 minus 10 to minus 6 and 1 minus 10 to minus 7. That's how you find it, and then you log those values in the spreadsheet. Okay? Here you go. 1 minus 10 to minus 6, 1 minus 10 to minus 7. That's the only thing that was missing for this. Let me erase that. So we start working on that right now. It's 9:26. Okay. Anybody else? Let's see here. Ernesto, are you good there, Ernesto? Is Ernesto still there?
Yes.
Okay. You're in good shape, Ernesto? Okay, good. Do you know how to get the CL? I presume that you know, right? Samuel, okay, I just talked to Samuel, right? Roy the book, the Buke. Are you there, Roy? Yes, I understand. Okay. So Kavi, Lay. Yes, good. Okay. Robert Supelsa. Good. Okay. Aidan Zamora.
Yeah.
Okay. Nathan Lilian. Nathan. Good. Okay. John Lortz. Do you know that? Do you know how to get the CL, John? John is not here. Yeah, I don't see John here. Okay. Left. Dino.
Yes.
Okay, good. Evin, Matthew, Hilario.
Yeah, we're good.
Okay. Ryan McNeil. Okay. Okay. Talking to parents. Okay. Joe Romero. Good. Franz Daring.
Yes, Professor.
Okay. Evan John. Good. Kevin Lopez.
Yes.
Okay. Roberto Melena.
Yeah.
Okay. So that's all I want to cover for today. Next time, you'll don't forget spreadsheet, upload, finish your spreadsheet, and upload it to your group folder, right? Before the beginning of the next meeting. It's not just the spreadsheet, but also the your spreadsheet and hard copy, okay, and hard copy report, and upload them to your group folder before the beginning of next meeting. Okay.
So, Professor,
Yeah.
so does that mean that we have, so we all have to turn in our own spreadsheet onto the folder?
No, per group, right? One spreadsheet and one hard copy per group.
Oh, okay. So there
Per
should
group.
be at the very least 2 files.
Yeah, 2 files. And the hard copy, right? You know what the format, right? Hard copy is right here. You're gonna have the spreadsheet and the format of the hard copy. Where is the format of the hard
Okay.
copy?
So it'll be on the syllabus pretty much.
Yeah, goes through the other factors. Let's see here. Library. At the top. Okay, here you go. 1, 2, 3, 4, 5. Okay. Title page. Tables. The tables you can copy from the spreadsheet and paste in your report. Copy the graphs and paste into your Word document, right? The error analysis is basically, let me show you the error analysis is this table here with the percentage difference. And, take a look at the lab report if there's any questions, and then you answer the questions there. Okay? So just, but make sure you do a nice, neat document that's easy to to read them, and it's gonna look good. Okay. So basically, I have that to you. If you don't have any questions, we can, can finish now, and I'll hang out in case there is anybody there that want to talk about the lab report. Any questions?
No,
Okay.
thank you, Professor, and nothing
Good.
from me.
Okay. So
I have a question.
yeah, who is that?
Oh, me, Robert.
Robert. Okay, go ahead.
Oh, sorry. Can you show how to input the min and max real quick?
Yes.
Sorry.
Here you go.
Thank you.
Here you go. Here you go. I got what? Equal. For this specific one, right? I got what? 1 minus 10 to minus 6. Okay?
Yeah.
1 minus 10, power minus 6.
Oh,
For
okay.
the other one, I got what? 1 minus 10, the upper and the lower and upper bounds, right? I call it
Yeah.
min and max. Ideally, I
Oh,
should
okay.
lower and upper bound. Or that would be, upper bound. That would be a better way. Does it have to be in bound? No. Just a Word document. It's Word document. You
Oh,
prepare.
okay.
You prepare that the hard copy has to be, it's hard copy between quotes. Okay, you prepare a Word document. That's what you do for the hard copy. The M on the
Okay.
table is the equation. Here you go. Is the equation. Here you go. See the equation here? Here's the equation.
Yeah.
Okay. You copy it and you paste it here. Here you go.
Oh, okay.
Okay. So the X is
Yeah.
in reality the V, right?
Yeah.
The X is reality the V. That's what you do.
Okay, I got it. Thank you.
Okay. Anybody else?
For the R2, I'm assuming you don't want it in scientific form.
Yeah,
Just
that's right.
normal.
Yeah,
Okay.
because it's very close to 1, right? You only put in scientific format if it's below 0.001.
Okay.
Okay? If the value is below 0.001.
I got a question.
Yeah, go ahead.
I don't remember if I asked this before or not, but if we do send a message to you on Canvas, is there like any? Oh,
Yeah, I don't check the canvas. Okay, you have to send me a message to my private email address. That's in the syllabus.
got
Okay.
it.
So I don't usually check Canvas. Okay, I don't. Sometimes I check the email from the college. But if you want to reach me, you gotta right away. I'm checking this email all the time. Okay, I
Got
don't
it.
have the habit of using Canvas.
All right. Thank you.
Okay, so just reach me on this email. Anybody else?
Thank you, Professor.
Welcome. Okay, if you wanna go, I'll still be around. Okay, if you're doing something else there, and if you don't have any questions, you can continue working there until you have any questions, and then you call me here. Okay. So I'll walk away momentarily from my computer, and if you have any questions, just call me through your mic. I'm gonna turn off my. I'm gonna stop sharing. Turn off my video and the mic, but I still be logged in. In case if you have any questions, just call me through your mic.
Oh, sorry. One more question.
Yeah.
When will you be uploading the recording?
This weekend.
Okay, thank you.
This weekend. I believe. By the way, I already have the recording of last week uploaded. Okay.
Oh, yeah. Thank you.
Okay.
Professor,
Yeah.
for that regular equation, that's just your y equals mx plus or minus b here.
Yeah, you're talking about the, let's see, the equation. Let me get the spreadsheet here. You're talking about the regression equation, right?
Yes.
Let me share that with you. Are you talking about this one here?
Yes.
Yeah, okay. Here goes this equation here. See that? The regression equation. This one for the ruler, this one for the vernier caliper. You copy it and paste here. And this other one that I didn't do for the micrometer, right? You copy and
Right.
paste here. The y is the m, the x is the v. That's why I put m equal to. It's an equation. It's an equation.
Okay, thank you.
Yeah.